All right, and now we're going to look at 8-3, quadratic functions in vertex form. It's going to be kind of an exploration version of a lesson, and our objective is we're going to investigate how changes in the equation of a quadratic function affect the graph of its parabola. Now, if you want, and if you have a graphing calculator with you, go ahead and grab that out, and you can kind of work along with me. I will be doing this on a online graphing calculator, so you can see what some of these graphs will look like as we change through them. Also, if you want, you can get out some graphing paper and draw out these graphs each individually, or if you want, just kind of off on the side on your notes, draw these out. Really, the main thing that I want you to write down is just kind of the words of what's happening from each of our equations. So in our example number 1 here, if we want to graph y equals x squared, y equals 2x, y equals 5x, and y equals 12x squared, all on the same axis. What we're looking for is we want to describe what happens to the graphs of y equals x squared when the coefficient of x squared is greater than 1. So here it's kind of a hidden 1, here it's 2, then 5, then 12. So as it gets bigger, what happens? Okay, and one way we can do that is we're going to look at this online graphing calculator. So as you can see over here, this red line, this shows us y equals 1x squared, so just the y equals x squared. Now if I add in y equals 2x, that's this green line here. Maybe if I zoom in a little bit, might be able to see it a little better. This is y equals 2x squared. Now if I add in another y equals 5x squared, notice that line and what's happening to it. And then let's do y equals 12x squared. It's this orange one here. So notice each time what happened to that line. Okay, so as we go back to our notes, one thing that you can say, or one thing that makes sense to me, is the parabola itself is getting narrower. Okay, and part of why that works, or why that is if this is our regular x squared, after 1, it's only 1 high. After 2, it's only 4 high. Well, if you add a coefficient in front of it, 2, 5, or 12, that means it's going to be going that much faster. So instead of after 1, it's only 1 high. After 1, it would be 1 times 2 high. That's why the green one is right here at 2. The purple one is 5 times as fast. So after x equals 1, it would be up to 5 high. So it's going up 5 times as fast. So that's why it looks like it's getting narrower or smaller, because it's moving up faster. Okay? So for number 1, the parabola gets narrower is what you should write as this coefficient of x squared gets bigger. For number 2 then, we need to graph y equals x squared, y equals 1/2 x, y equals 1/4 of x, and y equals 1/10 of x on the same axis. Describe what happens to the graph of y squared when the coefficient of x squared is between 0 and 1. So when it's a fraction like this. So we've got our graphing calculator again. Here is our 1x squared. This is 1/2 x squared. I'm using 0.05 x squared, so I'm using a decimal version. Notice it's on the outside. And here's the purple one. It's 1/4 of x squared. And 1/10, or 0.1 x squared on the outside of that. So again, notice how each one is getting wider. Now why does that happen? Same thing. If we look at y equals 1x squared, at x is 1, that's up at 1. When it's 1/2 x squared, it's only going up half as fast. That's why after x equals 1, our y is only a half. After x is equal 1 for the purple one, this 1/4, it's only up 1/4 of the way. Same thing, this orange one, it's only up 1/10, because it's only growing at 1/10 of the rate. So what can we say about this? What's happening? The parabola will get wider. What happens when the coefficient of x squared is a negative? Make a prediction and check your answer by graphing some examples. So if you want, go ahead and make a guess, see what happens. We're going to check it on the calculator then. All right, here we have our graphing calculator. Again, we start off with this 1x squared. If I add in a negative 1x squared, notice it looks the exact same, only it's flipped and it's going downwards. If I add in a 2x squared, remember that makes it narrower. If I do a negative 2x squared, it's still just as narrow, but it's flipped and now it's upside down. It's opening downwards. So what happens when we have a negative coefficient in front of x squared? Just move that out of the way. The parabola flips, so it opens down. So it did open up before, now it's going to open down. Example 4, graph y equals 5x squared. Oops, I'm going to underline these as we go. 5x squared plus 3, and 5x squared minus 7 on the same axes. Describe what happens to the graphs of y equals x squared when there's a number added or subtracted after the x squared term. So what's important here isn't this 5 out in front, because the 5 doesn't change. What's important is this plus 3 and this minus 7. So let's see what happens on the calculator. All right, so now we have the calculator. We have y equals 5x squared graphed right here. It's nice and narrow. If we add in the 5x squared plus 3, well, notice it's the same parabola, but instead of starting down here at 0, it starts up here at 3. Move this down a little bit, and we add in the 5x squared minus 7. Again, same parabola, just as narrow, only it starts down here at minus 7. So notice vertex up here at positive 3, vertex at 0, vertex at negative 7. So what happens when we add or subtract something at the back, behind there? Well, the parabola moves up when you add something, and it moves down when you subtract something. When I say the parabola, I mean the vertex. The vertex of that parabola is going to move upwards by 3. The vertex of the parabola is going to move downwards by 7. Example 5, graph y equals 5x squared. Y equals 5 times the amount x plus 3, quantity squared, and y equals 5 quantity x minus 7 squared, all on the same axes. So same thing, a plus 3 and a minus 7, but these are inside the parentheses, kind of along with the x value, before it gets squared. So we're going to graph all these on the same axis and describe what happens to the graphs of y equals x squared when there's a number added or subtracted inside of the parentheses. So let's see what happens. All right, we have our graphing calculator. We have y equals 5x squared. Just kind of, again, our normal one. Starts right here at 0, 0. If I add in the x plus 3 squared, notice, again, it's that same exact parabola, but it just moved to the left. How many spaces did the vertex move to the left? Well, it moved exactly 3 to the left. If we add in this x minus 7 squared and then times 5, again, that vertex, it was at 0. It's now all the way here at 7, or 7, 0. So the vertex moved to the right 7 spaces. So how does adding or subtracting something inside of the parentheses change it? The parabola moves left when you add inside the parentheses, and it moves right when you subtract in the parentheses. So this one is going to move right 7, this one is going to move left 7. And again, instead of saying parabola, you could say it's the vertex. That starting point, kind of that corner piece right here, this is the piece that moves, and then all the other points kind of move in relation to that vertex. So let's look at 6. Predict what the graph of y equals negative. So there's a negative here. If it helps, you can think of this as a negative 1 on the outside of this piece. So negative 1 times x minus 1 squared plus 6 will look like. So, and then we'll check our prediction. Let's think about what each piece does. If we have a minus 1 in here, a plus 6 in here, and a minus 1 on the outside, what would each of those pieces do? So think about that, and then we're going to check our prediction. All right, so we have our graphing calculator. We're going to check our way through here. We're starting with this y equals x squared. Now we're going to add in the x minus 1 squared. So in the parentheses, we added that minus 1. What did it do? It moved the vertex to the right 1 spot. Okay. If we add in this plus 6 at the end, what is that going to do? It's going to move the vertex all the way up here. So now we're at this spot. Now the only thing I'm going to do is add this minus 1 in the front, or a negative up front. Add that in. All it does is flip it, so it's going downwards. So if I take these away, this is what our parabola should look like. How does this one compare to this one? Well, again, that negative 1 out front flips it upside down. This negative 1 inside the parentheses moves it to the right 1. And if we subtract on the inside of the parentheses, it means go right 1. And when we add 6, it moved it up 6 places. So we got up to here. So this is what it'll look like in the end. And what does each piece do? The negative outside right here made it flip and open down. The -1 inside the parentheses moved it right. The +6 at the end moved it up 6 places. And 7, describe how the graph of y equals, again, we have a 2 on the outside. We have a +7 on the inside and a -4 on the outside. How that is going to be different from y equals x squared. Think about that for a second, make a prediction. I'm going to check it on the calculator. All right, we're going to start with our normal y equals x squared graph. Now inside we put in the x +7 squared. That +7 moves it over to the left, 7. So here's our vertex now. If we add the -4 at the end, that drops it down 4 places, and now it's here. And if we add the 2 out front, it makes it narrower, just like that. Okay, so the question might come up, what if I do it in a different order? What if I wanted to do the ×2 at the beginning? Well, let's see how that changes things. Okay, so let's start with the y equals x squared. Let's change it to y equals 2x squared. So we put the coefficient out first. Now we'll put in the +7. Again, it still moves it over. It's just now that it moved it over, it also kept it nice and narrow. And now we'll add in that -4. So still, either way you do it, whichever piece you add on, in the end, you'll end up right here with a new vertex, a new position, and a narrower parabola. So, describe how the graph changed from each of those pieces. The 2 out front here makes it narrower. The +7 on the inside moves it to the left 7 spaces. And the -4 at the end moves it down 4 spaces. So, some of our terminology. The vertex form of a quadratic function is a function written in the form f of x equals g, that's our coefficient, times the amount x minus h squared plus k. Okay, this f of x, remember, you can always replace with a y. Y equals this amount. Now g, the sign of that, is the direction of the opening. If g is a positive, then it points up. If g is a negative, the parabola is going to open down. So this one would look like this one would look like this, depending on if g is positive or negative. The absolute value of g is the width of the opening. If the absolute value of g is in between 0 and 1, so it is a fraction or a decimal, it makes a very wide opening. If it's greater than 1, it makes a very narrow opening. And if it's exactly 1, then it's our normal parabola. H is our horizontal slide. So positive h is going to move left that many units. Minus h, or negative h, is going to move right that many units. So minus h right here. And k is our vertical slide. If we add k, we're going up that many units. If we subtract k, we're going down that many units. Now a trick in this form, when you have this minus h plus k, your vertex will be at the spot h, k. So when it's written in vertex form, h and k, that is your vertex. That is your starting point of the whole parabola. So let's look at some examples here. Example 1, describe the transformation caused by each component of the function. Notice again, we've got a -2 and a -3. This is minus h, so h is our part of our vertex, should be at 2, and adding on k. Well, we're adding on a -3, so 2, -3 should be our vertex. And is it? 1, 2, down 1, 2, 3. Yes, that is our vertex. So when it is like this, vertex form, minus h plus k, h and k are your vertex. So, what do each of these parts do to our graph? If though it were to start from a y equals x squared, what would each piece do? Well, this -1/2 in the front, what does that do? It makes it wider, because it's 1/2, it's in between 1 and 0, and because it's negative, that means it flips it, so it's opening downward. What does this -2 in here do? Well, it makes it move the vertex 2 spaces to the right, 1, 2 to the right. This -3 at the end, what does that do? Moves the vertex 3 spaces down, 1, 2, 3. So it moved to the right 2, down 3, flipped upside down, and got a little bit wider, each of those pieces. Part B, describe the transformation caused by each of these pieces. Now there's no coefficient out there, so it's going to make the same exact kind of normal parabola. Again, we have minus h plus k. What are we subtracting here? Well, it's like we're subtracting a negative 1, because it should be minus here, but it's plus, so that's why this is minus. This should be plus, but it's minus, so this should be a minus here. Is negative 1, negative 2 the vertex? Negative 1, negative 2? Yes, indeed it is. So, in vertex form, you can always find the vertex as from these two numbers right here. So, what does this adding 1 or plus 1 do? It moves the vertex 1 space to the left, over this way. What does the minus 2 do? It moves the vertex 2 spaces down. So, left 1, 2 down, and then just makes our normal parabola. Describe how to translate the graph of f of x, or remember, we can replace y right there. F of x equals 0.04 x squared in order to produce the graph of each function. So if we have 0.04 x squared with a minus 1 at the end, notice this minus 1 is not inside the parentheses. So it's at the end, which means it moves the vertex 1 space down. In this case, we have a plus 7 in the parentheses along with x. So plus 7 in parentheses means moves the vertex 7 spaces left. Here we have a minus 2 in the parentheses and a plus 9 outside of the parentheses. The minus 2 means move 2 spaces to the right, and the plus 9 on the outside means move 9 spaces up. Last one, we've got minus 3 on the inside of the parentheses and minus 6 on the outside of the parentheses. Well, the minus 3 means move 3 spaces to the right. The minus 6 on the outside means move 6 spaces down. Example 3, we've got we've got 1/3 times the amount x plus 6 squared, and then minus 14 at the end. So, what are the coordinates of the vertex? Remember, you can always use this, and it'll be the opposite of this one and exactly what this is. So, opposite of the first one is negative 6. Exactly what this is negative 14. So the vertex for this piece, so moving 6 to the left and 14 down, would be negative 6, negative 14. If we need to find the y-intercept for any equation, you always just plug in x equals 0 and then solve. And that'll find you your y-intercept. So, if we plug in x equals 0, 0 plus 6 squared, then 1/3, all of that minus 14. Well, 0 plus 6 is just 6. 6 squared is 36. 1/3 of, or 1/3 times 36 makes 12. 12 minus 14 will become negative 2. So you could say your y-intercept is at negative 2, or if you like writing it as the actual point, it's the point 0, negative 2. This is your y-intercept. Example number 4, again, f of x, again, you can treat it as y, equals a negative, and if it helps you, remember, you can think of this as a negative 1 on the outside, negative 1 times this amount, x plus 1 squared, and then minus 4. There's a minus 1 on the, or a plus 1 on the inside, and a minus 4 on the outside. What are the coordinates of the vertex? Remember, it's opposite of this and this one exactly. So it's going to be negative 1, negative 4. This is going to be our starting point of this parabola. Find the y-intercept. Again, we're just plugging in x equals 0. So we've got a negative on the outside here. 0 plus 1 squared, and then minus 4 at the end. 0 plus 1 is just 1. 1 squared is just 1. So we've got negative 1 minus 4, which is going to come out to a negative 5. So our y-intercept is at negative 5, or you can think of it as the point 0, negative 5. And that'll wrap up our third video then.